Hello grade 11 students of Cauayan City National High School. Welcome to General Mathematics. In this video lesson, we will talk about intercepts, zeros, and asymptotes of the rational function. Okay, this video lesson is designed to help you to determine the intercepts, zeros, and asymptotes of a rational function. Knowing what a rational function is, you are now ready to learn its other properties. It includes finding the intercepts, zeros, and asymptotes. This will be your guide to easily determine the behavior of a rational function. The objective of this lesson is to know the meaning of intercepts, zeros, and asymptotes. Identify the intercepts, zeros, and asymptotes of a rational function, and then solve for the intercepts, zeros, and asymptotes of the rational functions. In the previous lesson, you learned how to find the domain and range of a rational function. In this particular lesson, determining intercepts, zeros, and asymptotes of the rational function will be done. Knowing fully the concept of the different properties of a rational function will be your guide to easily determine the behavior of the rational function. Again, the definition of a rational function is when two polynomial functions are expressed as a quotient and can be written in the form of f of x is equal to q of x all over r of x, and the q of x must not be equal to 0. And then, the domain of the function is the set of the first coordinates of the relation, and it is the value of x that will not make the denominator of the function equal to 0. And then, the range. It is the set of second coordinates. Okay, so let's proceed now to our topic, that is the intercepts and zeros of a rational function. The intercepts of the graph of the rational function are the points of intersection of its graph and an axis. The y-intercept of the graph of a rational function r of x, if it exists, it occurs at the r of 0. Provided that r of x is defined at x is equal to 0. To find for the y-intercept, simply evaluate the function at x is equal to 0. The x-intercept of the graph of a rational function r of x, if it exists, it occurs at the zeros of the numerator that are not zeros of the denominators. To find for the x-intercept, equate the function to 0. The zeros of the functions are the values of which x will take the function, and then the number of zeros are also x-intercept of the graph of the function. Let's have our first example. Find the x and y-intercepts of the given rational function, that is the f of x is equal to 2x plus 6 all over x minus 3. Let's solve. Let's find first what is the x-intercept. For us to get the value of our x-intercept, we will equate the function to 0. That is 2x plus 6 all over x minus 3 is equal to 0. Okay? So we know that we have that 0 has a denominator of imaginary 1. And when we have that form, we will cross multiply it. And 2x plus 6 multiplied to 1, that is 2x plus 6 is equal to x minus 3 multiplied to 0 is equal to 0. Transpose positive 6 to the other side of the equation, we will get a value of 2x is equal to negative 6. For us to get the value of x, we will divide both sides by 2, and we will cancel 2. And then, it will have a value of x. And then negative 6 all over 2, it will give us a value of negative 3. And that is our x-intercept. For our y-intercept, we will change all the x into 0. That is, f of x is equal to 2 multiplied to 0 plus 6 all over 0 minus 3. Okay? So 2 multiplied to 0 is 0 plus 6 all over 0 minus 3 is negative 3. Simplifying it, we will have 6 all over negative 3. And 6 divided by negative 3 will give us a value of negative 2. And that is our y-intercept. Next problem. Find the x and y-intercept of the zeros of the given rational function f of x is equal to x minus 9 all over x plus 3. Okay, let's solve. First, what is the x-intercept? Again, we will equate the function to 0. And that is x minus 9 all over x plus 3 is equal to 0. Alright, and then you know that we have a imaginary denominator of 1. We will cross multiply it. We will x minus 9 multiplied to 1 is x minus 9. Is equal to x plus 3 multiplied to 0 is 0. We will transpose negative 9 to the other side of the equation. We will have a value of x is equal to positive 9. And that is our x-intercept. For our y-intercept, again, we will change the x's to 0. And that is f of x is equal to 0 minus 9 all over 0 plus 3. Simplifying it, we will have a negative 9 and 3. Okay, dividing it, negative 9 divided by 3 will give us a value of negative 3. And that is our y-intercept. Okay, so next, find the x and y-intercept of the given rational function f of x is equal to x squared minus 10x plus 25 all over x plus 5. Okay, complex rational function. So again, the first step is to equate the function to 0, and that is x squared minus 10x plus 25 all over x minus x plus 5 is equal to 0. Okay, we know that 0 has an imaginary 1 as the denominator. We will cross multiply it. X squared minus 10x plus 25 multiplied to 1 is x squared minus 10x plus 25 is equal to x plus 5 multiplied to 0 is 0. And so as you observe, guys, that x squared minus 10x has a factor that is x minus 5 and x minus 5, that is equal to 0. As you observe, there are two values of x. So that is x is equal to positive 5 and x is equal to positive 5. Alright, so that is the x-intercept. For our y-intercept, again, we will change the x's to 0. And that is f of x is equal to 0 squared minus 10 times 0 plus 25 all over 0 plus 5. And 0 squared will give us a value of 0. Negative 10 multiplied to 0 is 0 plus 25. 0 plus 5 will give us a value of 5. Simplifying it, we will have 25 all over 5. And then 25 divided by 5, that is equal to 5. And that is our y-intercept. Okay, again, find the x and y-intercept of the given rational function. That is, the f of x is equal to x squared minus 9 all over x squared minus 3. So again, the first step is to equate the function to 0. And that is x squared minus 9 all over x squared minus 3 is equal to 0. 0 has imaginary number of denominator 1. Cross multiply it, we will have a value of x squared minus 9 multiplied to 1 is x squared minus 9. X squared minus 3 multiplied to 0 is 0. We will transpose negative 9 to the other side of the equation. We will have a value of x squared is equal to 9. For us to have the value of x, we will have a square our both sides, square root our both sides, square root cancel, and we have the value of x, and then square root of 9 is equal to 3, and that is our x-intercept. For our y-intercept, we will change the values of x's to 0, and that is 0 squared minus 9 all over 0 squared minus 3. Alright, so 0 squared is 0, and then negative 9 all over 0 squared is 0, negative 3. Simplifying it, it will give us negative 9 and negative 3. Okay, negative 9 divided by negative 3 will give us a y-intercept of positive 3. Asymptotes. An asymptote is an imaginary line. Take note, imaginary line to which a graph gets closer and closer as the x and y increases or decreases its value without limit. Take note, may forever. Kabaligtaran ng sinasabi nyo lagi na walang forever. Si asymptotes, may forever. So there are three kinds of asymptotes. The first one is the vertical asymptote. The vertical line x is equal to a if a vertical asymptote of the function f if the graph increases or decreases without bound as the x values approach a from the right or left, as you can see on the graph. Okay, to find for the vertical asymptote, first reduce the given function to simplest form. Then find the zeros of the denominator that are not zeros of the numerator. The second kind of asymptote is a horizontal asymptote. Okay? The horizontal line y is equal to b is the horizontal asymptote of the function f if the f of x gets closer to b as x increases or decreases without bound, as you can see on the graph. Okay, to find for the horizontal asymptote, compare the degree of the numerator n and the degree of the denominator d. There are three conditions. Take note of this. If n is less than d, the horizontal asymptote is equal to y is equal to 0. If n is equal to d, the horizontal asymptote y is the ratio of the leading coefficient of the numerator a to the leading coefficient of the denominator b. That is, y is equal to a all over b. The third condition is if n is greater than d. Okay, there is no horizontal asymptote with that situation. And the last one is the oblique or slant asymptote. An oblique asymptote is the line that is neither vertical nor horizontal. It occurs when the numerator f of x has a degree that is 1 higher than the degree of the denominator. Take note of that. To find for the slant asymptote, simply divide the numerator by the denominator by either using the long division or the synthetic division. The oblique asymptote is the quotient with the remainder ignored. Take note, the remainder is ignored and set equal to y. Take note of that. Okay, let's try this one. Determine the vertical asymptote and the horizontal asymptote of the given rational function f of x is equal to 2 all over 2x plus 5. Yan. Let's solve first our vertical asymptote. To find for the vertical asymptote, we will equate the denominator of the rational function to 0. That is, 2x plus 5 is equal to 0. We will transpose positive side to the other side of our equation, and we will have 2x is equal to negative 5. For us to get the value of x, we will divide both sides the equation by 2. Cancel 2. X is equal to, how many 2's are there in negative 5? There are negative 2 and 1/2. Okay? So for the horizontal asymptote, okay, we will apply the three conditions. First, if n is less than d, our y is equal to 0. If n is equal to d, okay, we will apply the formula y is equal to al over b. If n is greater than d, okay, there will be no horizontal asymptote. Yan. So, let's examine the function. As you can see, our numerator is a constant number. And then our denominator is a binomial. Okay, and it falls in the condition in our first condition, that is n is less than d. So our y is equal to 0. Next, determine the vertical and horizontal asymptote of the given rational function, that is f of x is equal to x plus 3 all over x plus 7. Okay, so let's solve first what is our vertical asymptote. And to solve for the vertical asymptote, we will equate the denominator of our function to 0. And that is x plus 7 is equal to 0. We will transpose positive 7 to the other side of our equation. X is equal to negative 7. That is our vertical asymptote. For the horizontal asymptote, again, we will use the three conditions. That is, n is less than d, okay? Our y is equal to 0. And then, if n is equal to d, we will make use of the formula y is equal to a all over b. And then, n is greater than d, there is no horizontal asymptote. Ayan. So let's examine our function. We have a binomial in our numerator and also in our denominator. Okay. So the highest leading coefficient of the highest degree of our numerator is 1. And also the highest degree of our denominator is 1. And the leading coefficient of our numerator is imaginary 1. And the highest leading coefficient of our denominator is also imaginary 1. Right, so they are equal. The degrees are equal. The degrees of our numerator and our denominator is equal. So, we will make use of the second condition. Okay? So, that is y is equal to a all over b. Okay? Our a is the leading coefficient of our numerator. Okay? That is 1. Our b is our leading coefficient of our denominator, that is equal to 1. And 1 divided by 1 is equal to 1. And that is our horizontal asymptote. Okay, next, determine the vertical asymptote and the horizontal asymptote of the given rational function. F of x is equal to the quantity of x plus 3 multiplied to the quantity of x minus 2 all over to the quantity of x plus 5 multiplied to the quantity of x minus 4. As you observe with our function, that is f of x is equal to x plus 3 multiplied to x minus 2 all over x plus 5 multiplied to x minus 4 is a very complex function. Okay, let's simplify it first. Okay, so that x multiplied to x is equal to x squared. X multiplied to negative 2 is negative 2x. 3 multiplied to x is positive 3x. And 3 multiplied to negative 2 is negative 6. All over x multiplied to x is x squared. X multiplied to negative 4 is negative 4x. 5 multiplied to x is positive 5x. And 5 multiplied to negative 4 is negative 20. Alright. So let's simplify. X squared negative 2x plus 3x, that is positive x minus 6 all over x squared. Negative 4x to positive 5 is positive x minus 20. Alright. So, masisimplify pa ba? Hindi na. So, that is our new function. Okay. So, let's make use of our new function. That is, f of x is equal to x squared plus x minus 6 all over x squared plus x minus 20. And let's solve for the vertical asymptote. Okay, we will equate the denominator of the function to 0. And that is x squared minus x plus x minus 20 is equal to 0. Okay, x squared plus x minus 20 is factorable. And its factor is x minus 4 multiplied to x plus 5. And it's very obvious that we will now have two values of x, and that is x is equal to positive 4 and x is equal to negative 5. Okay, for our vertical asymptote. For the horizontal asymptote, okay, let us examine first our function. Okay, the highest degree of our function. For our numerator, the highest degree of it is 2. And for our denominator, the highest degree of it is 2. So, they are equal. Our n and d condition, okay, na-meet natin. So, we will make use of the formula y is equal to a all over b. Okay, what is our a? It is the leading coefficient of the highest degree of our term. Okay, so the highest leading coefficient of our numerator is 1. Okay, and the highest degree of the leading coefficient of our denominator is the highest leading coefficient of the leading degree of our denominator is 1. Ayan, nabubulol-bulol na ako. So, okay, that is 1 all over 1. Okay, simplifying it, it will give us a y value of 1. Right, so that is our horizontal asymptote. Alright, so next, determine the vertical asymptote and the horizontal asymptote of the given rational function g of x is equal to 2 plus 3x all over x squared plus 3x minus 4. Okay, let's solve. Okay, so for the vertical asymptote, we will equate the denominator to 0. That is x squared plus 3x minus 4 is equal to 0. Okay, as you can see, it is factorable, and its factor is x plus 4 and x minus 1 is equal to 0. Okay, so we have two values of our x, that is x is equal to negative 4, and x is equal to positive 1. Alright, so for the horizontal asymptote, okay, we will examine first our function, okay, the whole function. So the highest leading coefficient, the highest degree of our numerator is 1. Okay, the highest degree of our denominator is 2. So are they equal? No. Okay, n is less than d. So our y is equal to 0. Alright, so that is for the problem 8. Determine the vertical asymptote and the horizontal asymptote of the given rational function g of x is equal to x minus 3 all over 2x squared minus 8. So let's determine first what is the vertical asymptote. Okay, we will equate the denominator of the function to 0. That is 2x squared minus 8 is equal to 0. Transpose negative 8 to the other side of the equation, we will now have 2x squared is equal to positive 8. Okay, we will divide both sides by 2. 2. Cancel. Okay, and the naiwan is x squared is equal to 8 divided by 2 is 4. Okay, let's apply square root for us to have the value of x. Okay, cancel square root. Okay, ang naiwan is x is equal to, what is the square root of 4? That is 2. Alright, so that is our vertical asymptote. For the horizontal asymptote, again, 3 conditions. Okay, but let's examine first what is the highest degree of the numerator and the highest degree of our denominator. The highest degree of our numerator is 1. The highest degree of our denominator is 2. So our n is less than the d. Okay, so our y is equal to 0. So napakadali lang mag-determine ng horizontal asymptote. Just consider the 3 conditions. Okay, the n is less than d, n is equal to d, and n is greater than d. Alright. So last one, determine the oblique and the slant asymptote of the given rational function. That is the h of x is equal to x squared plus 3 all over x minus 1. Alright. For us to have the value of our oblique or the slant asymptote, okay, we will divide the function. Okay, we will apply the division of polynomial, and that is x squared, okay, plus 0x, kasi nga wala tayong x, di ba? Plus 3 divided by, x minus 1. Okay, so x squared divided by x is x. Alright, so x multiplied to x is x squared. Okay, x multiplied to negative 1 is negative x. Okay, so let's subtract. Okay, so x squared minus x squared is cancel. So 0 kasi yan, 0x squared. Sulat pa ba natin? Hindi na. Alright, so 0x minus negative x. O, diba kung negative to at meron yung process na subtraction, magiging positive siya. Magiging positive siya. So 0 and then magiging addition yung process. Magiging addition yung process dito. Okay, di ba? Ganun yung process ng subtraction. No? So 0x plus positive x will give us 1x or just x. Okay? Bring down positive 3. Okay, so x divided by x is what? Positive or negative? Positive 1. Alright, so 1 multiplied to x is x, and 1 multiplied to negative 1 is negative 1. Alright. So, subtract again. X minus X is 0x. Hindi na kailangan isulat. Okay? So, plus positive 3 minus negative 1. Magiging positive to. At yung process magiging addition. Positive 3 plus positive 1 is positive 4. Alright, so again, for us to determine the value of our oblique and slant asymptote, the denominator is disregard. Yan. So, the answer for our slant asymptote or the oblique asymptote is equal to x plus 1. Alright, so ayan, ganyan yung solution ng pagkuha ng oblique or the slant asymptote. Okay, pwede din kayong gumamit ng synthetic division. Alright? Take note of that. Okay, so remember guys that to find for the y-intercept, substitute 0 for x and solve for the y or f of x. And to find for the x-intercept, substitute 0 for y and solve for x. And the 0 of the rational function, take note, is the same as the x-intercept of the function. Right. And then, an asymptote is an imaginary line to which a graph gets closer and closer as the x or y increases or decreases its value without limit. Okay, my forever. To find vertical asymptote of the rational function, first reduce the given function to simplest form, then find the zeros of the denominator that are not zeros of the numerator. Okay? To determine the horizontal asymptote of the rational function, compare the degree of the numerator n and the degree of the denominator d. Okay? The three conditions are, if n is less than the horizontal asymptote, your y is equal to 0. If n is equal to d, the horizontal asymptote y is the ratio of the leading coefficient of the numerator a to the leading coefficient of the denominator b. That is, y is equal to a all over b. Okay, make use of the formula kung sakasakali. Okay, so and then the last, if n is greater than d, there is no horizontal asymptote. Right? So last, an oblique asymptote is a line that is neither vertical nor horizontal. It occurs when the numerator of our f of x has a degree that is 1 higher than the degree of the denominator. Divide the numerator by the denominator by either using the long division or the synthetic division. The oblique asymptote is the quotient with the remainder ignored. Take note, remainder ignored and set equal to y. So that ends our lesson. Thank you for watching. I hope that you learned something. If you have clarification, question, or reaction in my video lesson, please message me in my messenger account, that is Kim Francis, Season and Love. Okay, so I hope that you learned something. Enjoy and stay safe. Bye! Right.